Okay, this is Algebra lesson 6.3. Elimination using addition and subtraction. We're going to be solving a system of equations by using addition and subtraction. Okay, so I'm going to put this one I just put back up there. It is 4x plus 6y equals 32, and 3x minus 6y equals 3. Okay, I asked you, would you like to solve this by graphing? The answer is no. Couple of reasons. One, big, huge numbers. You don't want to be graphing numbers above like 10. Agreed? If there's any number above 10, then you're not going to want to graph that. If you also, in order to graph it, you need to solve it. You got to get in slope-intercept form, which means you got to solve for y. And you can tell this is going to be ugly, right? There's going to be fractions as your y-intercept. It's just going to be a mess. So this is not conducive to graphing, okay? Also, would we use substitution here? No, why not? Could we use substitution here? Yes, we could solve for an x or solve for a y. It would just be a mess again, right? All of a sudden, we're going to have this big, huge fraction that we have to go plug in, and that's no good. That is not easy. A different method is what's called elimination. Okay, we're going to eliminate something. We're going to eliminate by adding or subtracting here. Here's how you eliminate. So pay close attention. We're going to either add these two equations together, or we're going to subtract them from each other. This is the whole purpose behind this. Look, what you're looking for when you're going to decide to add or subtract is you're looking for the same number here. 4x and 3x, are they the same? No. Is 6y and 6y the same? Yes. So here's the deal. I have a plus 6y up here, and I have a minus 6y here. If I added those two together, if I added a plus 6y and added it to a negative 6y, what will that give us? 0. That will eliminate them. Does that make sense? If I add them together. So what I'm going to do is this. I have to add the entire equation to the other entire equation, and that will eliminate the y here. Let me show you. I will show you how to do this. I'm going to leave that up there so we can see. 4x plus 6y equals 32, and 3x minus 6y equals 3. Just like a regular old addition problem. Okay? You're going to leave the equal sign in the same spot, but watch what I do. This is very important. I'm going to add them together. I need to put parentheses around this and put a plus sign out here. Just like if I was going to go, set 4 plus 3. Notice there's a plus sign out here. Otherwise, I wouldn't know what to do. If I just put a 3 here, you go, well, what am I doing? Am I adding? Am I subtracting? Am I multiplying? Am I dividing? I don't know, right? You have to put that plus sign out here. No different than what we're doing here. There's one, and we're going to add it to the other. It's important that you put the second one in parentheses. Trust me, in about 5 minutes, I'm going to show you why it's so important. But it's important that you put that plus sign there. So here's what we're going to do. Everything gets lined up. This is just like regular old addition. Now notice this. I'm going to do this in red so you can follow along with me. What is 32 plus a positive 3? Do you see how that's a positive 3? 32 plus 3 is 35. Put your equal sign down there, right? Everything comes down. Equal sign comes down. What is plus 6y plus a negative 6y? Notice this. It's a plus minus, right? Do you see that this is plus a negative 6y? Plus minus simply means minus, right? So, okay, in this situation, it's no big deal, but it just means minus. What is 6y? Take away 6y. 0, right? I could put a 0 down here. I'm not going to because I don't need to, but I could put a 0 down there. What is 4x plus 3x? I've eliminated the y. Now we're going to go divide by 7, x equals 5. Oh my goodness. X equals 5. Make sense? Now, what do you think I do with that? If I have x equals 5, what do I do with that? Go plug that into either one. Go plug it in. Go plug x equals 5 in either one. We'll do the bottom one. 3 times 5 minus 6y equals 3. That would be 15 minus 6y equals 3. I gotta move, give myself some more room. Minus 15 minus 15. Negative 6y equals negative 12. Divide by negative 6, divide by negative 6. Y equals 2. Oh my goodness. Y equals 2. 5, 2 is the answer. If we were to graph this, what answer would we come up with? 5, 2. If I was to go through the whole long, ugly process of using substitution, what would I come up with? 5, 2. These are just two lines. This is just one way of figuring it out. How can I know that this is true? What can I do to check my work? Could you graph it? Sure. That takes forever, right? So what's the quickest and easiest way of checking this? Plugging it into both, right? Making sure that if x is 5 and y is 2, is it true for both? Yes. Okay, makes sense. Okay, you guys try one. Let's try one. Let's do, let's do one that's kind of weird here. Negative 4x plus 3y equals negative 3, and 4x minus 5y equals 5. Okay, you go ahead and do that one. Watch. Here's the deal. This is important, and we haven't gotten to the subtraction one yet. But what am I going to do with these? Am I going to add them together, or am I going to subtract them? I'm going to add them because, and what am I going to be eliminating here? The x's, right? I'm going to be eliminating the x's because they're conducive to that. I have a negative 4x and I have a positive x. So what am I going to do with them if I have one negative and one positive? Is I'm going to add them together. Does that make sense? Add them together, that's going to make 0. That's what I want. So let's do that right here. Add. Don't forget to put parentheses. How many of you remember to put parentheses around the bottom? I'm telling you right now, you better remember that because when we start subtracting, it matters. Here's the deal. So here we go. We're going to do this. I'll do it in blue. Negative 3 plus 5. What is negative 3 plus 5? 2. So the equal sign comes down 2. What is 3y plus a negative 5y? That is negative 2y. What is negative 4x plus 4x? 0. It's gone. I leave it. Oh, we're done. This is easy. Divide by negative 2. Divide by negative 2. Y equals negative 1. Okay. Y equals negative 1. That's easy. Plug it into which one? Doesn't matter. Plug it into the bottom one. 4x minus 5 times negative 1 equals 5. 4x plus 5 equals 5. Minus 5 minus 5. 4x equals 0. What does that mean? X equals 0, right? X equals 0. 0, negative 1 is how you would answer that. How many of you got 0, negative 1? Good, not difficult. The addition ones are easy. Here is one that is a subtraction one, okay? Here's the deal. They look like this. It would look like this. 2x plus 5r equals 6. And 2x plus 9r equals 22. Now, I want you to look at this. This is how you have to recognize this. Got to recognize this. How do I eliminate these? What is going to actually eliminate something is if I subtract them, right? I've got these. There's a 2x in front of both those, right? There's a 2x in front of both. The only way to eliminate them would be to subtract one from the other, right? Adding them together, it's going to make this be a 4x down here. Does that make sense? That's not going to help. Doesn't do anything. So I'm going to subtract them. So I put a minus sign out here, and I have to do this because I'm subtracting. Make sense? Now, here's how this works. Here's how it works. I'm going to go 6 minus 22. What is 6 minus 22? Negative 16. Does that make sense? It's 6 minus 22 is negative 16. What is 5r? Take away 9r. Negative 4r. 2x minus 2x is 0. It's gone. Divide by negative 4. Divide by negative 4. R equals 4. Plug it in. We're back to where we were. Makes sense? Okay. What about this? There's some that are ugly here. Let me get you one that's nice and ugly. Okay, what about this? Let me look at this here. Okay, yeah, I like this one. Here's a good one. Here's a hard one. You guys try this one. I'll be impressed. Negative. Oh, yeah, no, hold on. Hold on. No, come on. Maybe they don't give them that hard. I don't know. Here's kind of an easy one. Okay, what about this? Y plus Z. Oh, this is actually, hold on. A plus B, I'm going to do a good one for you, equals 4, and then A minus B equals 8. Now, before we even do this, here's the deal. I don't see any X and Y's. How are we going to do this if there's no X and Y's? A and B, they're just variables, right? Isn't X and Y just variables? Couldn't I put banana plus smiley face equals, right? I could do whatever, right? So then, which one's X and which one's Y? Why? What is the reason? That's true. Why? It's alphabetical order, right? In alphabetical order, that's what you do. So then don't let this bother you. And listen, on these types of questions, what method could you use to solve these? You could graph these really easy, agreed? Because remember, those are both Y's. You could do that. What else could you do if you wanted to? Wouldn't it be easy to substitute? Or you can use elimination, which is what we're doing, adding or subtracting. And would you add or subtract these? You could subtract to get rid of the A's, or you could add to get rid of the B's. Does that make sense? It doesn't matter. You've got all sorts of options here, right? So use addition or subtraction. You choose, I don't care which one, to solve this one for me, okay? Right now, that's what I want you to do. Okay, so here we go. Here's what happens. I don't like to subtract only because there's more work to do. Okay, so I want you to add these things together. I would add them, whatever. You can choose whichever. Let's add them. 4 plus 8 is 12. B plus negative B is 0. What is A plus A? 2A. Divide by 2, A equals 6. So that would be 6 here, right? And then go and plug it in. If A is 6, 6 plus what equals negative 2? If A is 6, 6 plus what equals 4? Negative 2, right? So then B equals negative 2. How many of you got that? 6, negative 2. Okay. How many of you subtracted instead? Okay, let's show that makes no difference. A plus B equals 4. A minus B equals 8. Here's the deal. Let's subtract it. What is 4 minus 8? Negative 4. What is B minus a negative B? What does minus a negative mean? It means plus. So B plus B is 2B. A minus A is 0. 2B. So divide by 2. B equals negative 2. Go back up and plug it in. If B is negative 2, what plus negative 2 equals 4? 6. We're still here. Does that make sense? Does not matter whether you add or subtract in this situation. Right? Okay, let me give you one here. Here's a good one. A complicated one. Okay, there you go. Okay, so here we go. What's the first thing I need to do here? I need to get them to look like a system of equations, right? I need to get them to look linear. I need to turn them into standard form. Agreed? Are they in standard form right now? No, the top one is not. Rainbow, rainbow. So 4x plus 8y equals 8. Now, is it okay that this one's on the bottom? Does that change anything? No, it's just two lines, right? It doesn't matter which one comes first. They're just two lines. It's wherever the lines cross. What am I going to do? Add or subtract to get these to be eliminated. So remember, look, see, same number, right? 4x. I'm going to subtract. 12 minus 8 is 4. 4y minus 8y is negative 4y. 4x minus 4x is 0. Divide divide by negative 4, divide by negative 4, y equals negative 1, right? And then plug that into whichever one we want. Top one, sure, 4x plus 4 times negative 1 equals 12. 4x plus, minus 4 equals 12 plus 4 plus 4. 4x equals 16, divide by 4, x equals 4. How many of you got 4, negative 1? Does it make sense? This addition and subtraction, like I said, the hard part is that right now, while we're doing just addition and subtraction, you're like, oh, that's easy. Yeah. Come someday when I say, okay, tell me the answer to this problem, you're going to be like, ugh. Right, you got to know what you're allowed to do. Tomorrow's lesson, and actually not tomorrow, we'll do a review tomorrow. But tomorrow, the next time we have a lesson, it will be this. I will show you the next step, okay? And I'll say I want you to solve that. Do you agree this is a line? Do you agree this is a line? Yeah, and all of a sudden you go, okay, so is graphing this going to be the best choice? No, definitely not. Is using substitution going to be the best choice? No, there's no x or y that's alone, okay? What about adding and subtracting? Is that going to eliminate anything? No. Ooh, wait a second. There's nothing that works here. So this is what you have to do. What are you allowed to do to any equation? What are you allowed to do to any equation? Anything you want. You can do anything you want, as long as you do it to both sides. So here's the deal. What you can do is this. You're going to look at this and go, wait a second. Oh, wait. What if I took this entire top equation and multiplied both sides by 2? What if I multiplied everything here by 2 and turned this into rainbow, 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 right? And said it's now 4x plus 6y equals 16. You see that this and this are identical. All I did is multiply both sides of that equation by 2. Oh, and now, is this conducive to subtracting? Do you see what I'm saying? So then that's the next step to this. Okay, now we're getting closer to the top of the hill. Make sense? Anyway, your lesson for today, however, page 352, 7 through 18 even. I'm going to make sure that that's what I want. Yeah, that's... I'll tell you now, there are I won't tell you which ones, but there are 2 of them that do not come out to whole numbers. Okay, there are 2 answers that do not come out to whole numbers. What do you do if you want to make sure that you got the right answer? Check it, right? Check it. 2 of the answers are not whole numbers. No. I'm just letting you know that you haven't made a mistake when your answer comes out to something that isn't a whole number. 2 times that will happen.